Hello, I'm Christian Bernstone from Vattenfall in Sweden, power company, and I've been involved in CCS since early 2000, and Vattenfall then decided to stop our activities in this area in around 2013. And since then I've been working with other tasks, but now it's popping up again, considering projects in Sweden. That's what I'm going to talk about. So my background by training is civil engineering and petroleum exploration. Let's see here. Pointer. Yeah, so this is where we have our operations today. The company is based in Sweden. It's a fully owned company by the Swedish state. We have operations in Germany, Denmark, the Netherlands, and the UK. And as I mentioned, we've been involved in CCS before. This is our plan for rolling out CCS as it looked like in 2000, where we started with theoretical investigations and then continued with test rigs, a pilot plant, and we were well on the way to do a demonstration plant in Germany and then continue with commercial concepts by 2020. But then we had the financial crisis and the business case disappeared. Not the only reason, but that was the reason why the plans changed. So what we are doing now is definitely on a different scale than we did in the past. And the same applies to storage. At that time we were engaged in the full chain, working on CO2 capture, the transport part, and also on the storage part. This is not the case anymore. Vattenfall has a commitment toward net zero. We have reduced our emission intensity since 2017 by 49%, and of course a lot of that is due to the divestment in fossil fuel power generation in Germany and other countries. We have a target for our own emissions reduction to be in alignment with the 1.50 trajectory and to be net zero by 2040. Here is a map of our generation, which is wind, biomass, hydro, gas, nuclear, some coal still, solar, and district heating. And what is relevant for my talk today is biomass and district heating, where we have operations in Sweden, Germany, and the Netherlands. We have two ongoing projects. One is CCS and one is CCU. So the one on CCS is in a combined heat and power plant in Jordbro, which is very close to Stockholm. And we have a CCU project in Uppsala, which is north of Stockholm, where this CO2 is intended to be used for aviation fuels in a project partly funded by the Innovation Fund named High Skies. But I will not talk about the CCU project, now more on the Jordbro project, where the target is to remove about 150,000 tons of CO2 per year and to have start of operation in 2027. But this is then dependent on state aid. The Swedish state has given the task to the Swedish Energy Agency to prepare a support scheme for Bio-CCS through a reverse auctioning process, where the state will cover the cost for the full chain from capture, transport, and storage for a binding period of 15 years. The first stage, it aims to be storing 2 million tons per year from 2030, and that should then come from 3 to 5 plants. And the first auction is to be announced this year with 600,000 tons approximately CO2 storage annually from 2026, as it says here, but there has been a delay and we consider it now to be 2027. But since we haven't seen the final call yet. We don't know the details, but we are working in our project towards 2027. And after the first auction, there will be two more auctions later on. So the power plant, you see the location here, south of Stockholm, and we are aiming for a port named Norvik, which is also in the Stockholm area. The plant is 70 megawatt, and we have a fuel from recycled wood chip. We have operating hours of 6,500 hours per year, and lower during summertime. And for our project, we want to buy everything on commercial conditions. So for the capture, it will be a turnkey solution, which we can buy on the market today, and that as well goes with the transport part and the storage part. And that is, as you all know, an emerging market, but we think it can be done. So the transport part, forgot to say that on this slide, but we have a railway connection very close to the power plant, so we foresee that we can handle the transport to the port by railway. And by doing that, we want to use what is named as a block train setup, where you have a number of wagons or cars with cryogenic tanks that can be set up on a track and then be used as a intermediate storage. And when the train is filled, we can there will be the operator of the train will come and get the cargoes, the wagons, and transport them to the port, and by doing that, leave another set of wagons at the site. We will not fully rely on that, but we don't need that large of intermediate storage capacity at the plant site by this setup. So the distance to the hub is about 3.5 or 35 kilometers, so it's fairly close. So this is our main option today, but as soon as you have the CO2 on cryogenic tanks, of course, it's also possible to take the train somewhere else. But this is a favorable port has a favorable conditions. It's fairly new. There is a new roll-on, roll-off terminal, and it has a high capacity train connection. It's operated by Port of Stockholm, which have several ports in the region. It has good drought conditions with about 16 meters and can take ships up to 400 meters length. So the intention here is to build a new purpose-built quay for CO2 transport and the installation that is needed for that. The space is there. So there has been an initial study that points out it's possible to have CO2 volumes handled in the port, about 500,000 tons per year in 2026-27, and to increase that into megaton scale in 2035. And it has an advantage location compared to other ports in the region, very close to open sea. This is now being developed in a collaborative project, NICE, which is owned by Port of Stockholm, to realize Norvik as a storage terminal for capture CO2 from this region. So to conclude, not only Vattenfall, by the announcement by the Swedish Energy Agency about the reversed auction, there has been a very large interest in Sweden to develop Bio-CCS projects. So we foresee, of course, a competition for the available funds. But we believe that we have a project with good conditions for implementation to create negative emissions. And we believe also that there are actors that can offer the services that we ask for, but as you all know, the decision-making processes of these actors need to coincide in time so that all services can be put into use at the same time. That is around 2027. Thank you.
Thank you.